You've learned how to set up Luna HSMs and manage keys. Now, how do real applications actually use those keys without ever touching them directly? That's where PKCS number 11 comes in, the standard API that connects your code to HSM partitions and their cryptographic operations. You now understand what a Luna HSM is, how clients connect, and how keys live inside secure partitions. PKCS number 11 is the next piece. Think of it as the bridge that lets real application code safely use those keys for cryptographic operations without exposing the key material itself. PKCS number 11 acts like a contract between your application and the Luna HSM. Your code just says sign this, encrypt that, or generate a key using a standard set of functions. Behind the scenes, PKCS number 11 opens a secure session to the Luna partition, locates the right key, and runs the operation in hardware. The key material never leaves the HSM, while your application gets the cryptographic results it needs in a consistent, portable way. You can picture the PKCS number 11 data model as layers you move through. Your application first loads a module, which is a shared library implementing the PKCS number 11 API. Inside that module, you discover slots, each representing a logical access point. A slot may expose a token, the secure container that actually holds keys. From there, you open sessions to the token, and within those sessions you create, read, or modify objects such as keys, certificates, or generic data. When you code against Luna using PKCS number 11, you're really interacting with those same layers. The module is the Luna client library your application loads. Each slot corresponds to a configured Luna partition you can reach. The token is the logical cryptographic container for that partition, and the objects are the actual keys, certificates, and data you operate on. Choosing the wrong slot or token means you'll be talking to the wrong keys. To actually talk to the Luna HSM, your application must load the Luna PKCS number 11 shared library at runtime. 3 checks matter here. Luna client must be installed on that host. The library path you configure must match the real install location for that OS and client version. And the architecture has to match. A 64-bit process needs the 64-bit library, and a 32-bit process needs the 32-bit one. A PKCS number 11 program always begins by loading the vendor's library, then calling cinitialize to bring the module into a known usable state. Next, it calls cGetSlotList to discover which slots are available, often requesting only those with a token present. For each candidate slot, cGetTokenInfo returns metadata such as label, manufacturer, and capabilities. Rather than hard-coding slot numbers, applications should select a slot based on this information or external configuration. Now think of PKCS number 11 access as walking through a series of doors. First, the client itself must already be trusted and mapped to a Luna partition. Without that, nothing else happens. Next, your application calls zOpenSession to create a read-only or read or write context bound to a specific slot. Only then does cLogin authenticate a user role, unlocking private and sensitive objects so authorized key operations can run within that session. PKCS number 11 treats every key or certificate as an object described by attributes. Identity attributes like CKA label and CKA ID answer, which object is this, and are what your code searches on. Usage attributes define what is this object allowed to do, such as CKA SIZ, CKA grept, or CKA verify, or CKA verify. Security attributes like CKA sensitive and CKA extractable control whether key material can ever leave the module, aligning behavior with your key protection policy. Applications never pull private keys out of the HSM. Instead, they search for key objects and receive opaque handles in return. In code, you build a template, such as give me a private key with label app signing key, then call cFindObjectsInit, loop with cFindObjects to collect handles, and finally call cFindObjectsFinal. Each handle is just a temporary reference for that session, so consistent labels and IDs are what make your design predictable and maintainable over time. PKCS number 11 mechanisms are the glue between a key and a specific cryptographic operation. You're not just saying sign or encrypt, You're saying sign with RSA using this padding, or encrypt with AES GCM. Each key type only works with certain mechanisms, based on its attributes and the partition's capabilities. So when you initialize sign, verify, encrypt, decrypt, or key generation, always query the token's supported mechanisms instead of assuming they're available. Most PKCS number 11 operations follow the same basic pattern. You start by initializing the operation with something like csign init, cverify init, or cencrypt init. That call selects the mechanism key and any parameters. Then you feed data into the operation with csign, cverify, or cencrypt and get the result back. For large data, you switch to the multi-part variants, but the mental model stays the same. Initialize, stream data, finalize. Think of runtime setup as 4 checks you need to pass. First, the application must load the correct Luna PKCS number 11 library file, including the right architecture. Second, environment variables like path or LD library path must include that location, or your framework's module setting must point to it. Third, the Luna client configuration has to reference the correct appliance and partition. Finally, confirm that the service account can read all required libraries and configuration files. Imagine your application suddenly can't find the signing key after deployment. Start by comparing environments. Are you using the same slot, token label, and key attributes as in test? Then review PKCS number 11 return codes. A failed login, invalid mechanism, or bad object handle each point to different fixes. Finally, log enough context to replay the failure later, but never include pins, key material, or raw payloads in those logs. Take a moment to zoom out. You've seen how PKCS number 11 concepts map onto Luna's libraries, sessions, and keys. In the next step, we'll bring this to life with concrete language-specific integrations and real-world implementation patterns.